It's bloated.
So this song, Kualena, is about flowers and comparing somebody that we love to the beautiful fragrance of our favorite flower. We're going to start off with some basics, so everybody stand up. Kuilu now. Kuilu na stand up. Everybody hands in your hips like this. If I sound a little winded, it's just because there's another baby in here.
Those two chemicals, the A and B, needed time to change. That's why in science we call that a clock reaction. And look at this.
Whoa!
Let's try yet. That's right, another experiment.
Oh my goodness! Look at that.
commercial. This is BP. Yes, that's it. Draco. His tongue, watch his tongue. See his tongue? So every time Oreo sticks his tongue out, just like a snake, he can find out where food is. Just like that. So if you're a tree frog, you drink through your belly. So everybody pat your belly like that.
Hello everybody, my name Golder the Tortoise.
Go like that with your hands. And everybody look at your hands. And everybody say, glands on your hands. Everyone stick your tongue and go, and then go like that with your fingers. Say, fork tongue. For now, everybody, wave goodbye to BP. Just wave so she can see you. And stomp your feet, stomp your feet, stomp your feet. Bye, everyone. Thank you very much. Thank you, thank you, thank you. Thank you.
We're going to be doing a very special show today, a show for Mother's Day.
Hi there. My name is Mystery Matt.
Where is the puppy? Where is the puppy? We're going to find it. Where is the puppy? If any of you see a clue, I want you all to shout, clue!
I am Dr. Lazarus. I am a puppy scientist.
And this just might be a clue. Here, puppy, puppy, puppy!
Let's say there's somebody standing behind you, and they see that you're covering the hole with your thumb. So what do? You look around, snap your fingers one time, blow on the egg, and when you spin it around, there's no hole. Here we go. Look. Watch. Oh, it's becoming. It's becoming. SpongeBob has disappeared. Ta-da, you see? He's gone. All right. What? You think he's at the Krusty Krab? He's not at the Krusty Krab. There we go. Look at that. How about now? Huh? What? Look at the different car. Look at that. Look at this. Whoa. In comparison.
If you are ready for more, make some noise!
My name is Captain Magic, and today we are going to do a bit of a pirate magic show. This is Pee-wee. Can I say hello, Pee-wee? What's Pee-wee? Say the magic word, R. And the pirate man turns around. Oh, I tricked myself. What do you guys think? Ah! 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 Oh.
Hello, everyone. I'm Hop the Tree Frog. Thank you for joining us today. And wait, look what he's doing. He's sticking his tongue out. Look at his tongue.
Are you having fun? 5, 4, 3, 2, 1, I'm done. Party like it's your last night.
Boy.
right, are you guys ready to see some magic now? I actually brought something special with me today. I brought something special. It's the most rare thing you could find right now. I got something really cool. Do you guys know what this is? It is not. It is magic paper. Put your hands out like this. What I need everybody to do is I need you to wave your hands up and down like this, up and down like this, up and down like this, up and down like this.
What? Oh my gosh! Ow!
We're going to have a banana. Really. That's not the magic word. What's the magic word? Ew. That was gross. Check it out. We actually have here the stripes, the stars, the American flag. Look at that. Nice work. Look at that. Beautiful job. Wait a minute. Something's wrong here.
Oh,
wait. It's backwards, right? It's backwards. I'll fix it. We're going to squeeze it up tight. All right. Everybody's going to start mixing like this. Everybody's going to start mixing like this. Everybody's going to start mixing like this. On the count of three. Everybody's going to mix abracadabra really loud. Ready? 1, 2, 3. Abracadabra. We have here these stars. We have here the stripes. We have the American flag. We're gonna do is everybody's gonna start drawing like this. Everybody's gonna start drawing like this. Everybody's gonna go like this. We're gonna go like this. Everybody's gonna go like this. Everybody's gonna go. You want to see what happened?
I draw.
You want to see? All right, let's see. Are you sure? Look at this in here.
Yes. Whoa.
Go. What I need everybody to do is we're gonna go backwards like this. One last time. We're gonna go backwards like this. Everybody's gonna go erase. Sure?
Yeah.
Okay.
Yes.
One last time. Let's take a look. Check it out. Whoa. All the pictures are gone. The book is empty. Give yourselves a huge round of applause, guys. That was an awesome job. Fantastic work. All right, we're going to do one last thing for you guys today. One last thing. We're going to try one last trick. And I need everybody's help with this last part, okay? On the count of three, I want everybody to say, I love magic really loud. Ready? 1, 2, 3. Thank you guys so much. You guys are an awesome group. Give yourselves a huge round of applause. You guys are amazing. Thank you guys so much. My name is Magic Steve. And that's gonna be
Thank you, Magic Steve. Thank you so much.
Good times, good friends, they're here to stay. A good day today. Blue skies, the sun won't go away. A good day today can keep the smile off my face. No rain, no cold, no blues, no gray. A good day today. Good times, good friends, they're here to stay. A good day today. Blue skies, the sun won't go away. A good day today can keep the smile on my face.
Coming
Happy birthday, Noah. Can't wait to see you.
Okay, this is Vinny Voltage. I'd like to welcome you all. Okay, and well, of course, we're a part of the Magical Memories, and we have a science show for you today. Okay, now we're going to look over here. But before that, we're going to talk about elements, science, elements. And the lightest element that we know is, I'm sure you know too, is hydrogen, which is H2. And hydrogen is a part of water with oxygen. So if you see over here, I have this jar right over here. This jar, this tube, and this little cup. I'm going to move my camera just a bit so we can see it all so very well. All right. Let's see. Here we go. Okay. I'm going to move this out of the way. And here it is right over there. Now, what I'm going to do is electrify the water. Okay? All right. I have no idea. Okay. Now you're ready. Okay. Oh, maybe I'll put it, I'm side. I have to go this way. Is that it? Okay. I guess I'm right now. Okay. You ready? Let me see if I can get my thing to work. Okay. Okay, so we're going to do an experiment with hydrogen. We're back. Are we back? All right, we're back. Okay, so we're going to do experiment with hydrogen. Okay? And I have right over here a hydrogen generator. Let me do it like this. Okay, I don't get it today. All right. Okay. We have a hydrogen generator right over here. All right, right there. And then we have our cup of soap over here. Okay? All right. Let me do this like this. Okay. So what I'm going to do is I'm going to add electricity to this hydrogen. Okay. Okay. So now we have bubbles forming inside here. Okay, you see the bubbles forming in there? The bubbles right in there? Okay. All right. Now I'm going to light those bubbles. I'm going to give it a light with our little lighter. Okay. Okay, here we go. So we're going to light them. Ready? Boy, I have a little trouble with this camera today. Okay. Whoa. You guys heard that? That's the explosion of hydrogen and oxygen. Let's try that again. Okay, there it is right there. If you could see it, if I have it right on the one. Okay. Raise it up a little higher. Okay, can you see it? All right, we'll try it again. Oh, boy. So hydrogen is very, very explosive with oxygen. Okay? All right. Now we'll try it again. Let me put the camera right this way then. Okay, you can see me up vertical. Okay. There we go. All right. Very good. So we'll try that one more time. Okay. We're making the hydrogen gas. I'm lighting it with my little lighter right over here. See that? Whoa, you hear that pop? That is incredible. And this is hydrogen plus oxygen being actually worked. Again, one more time. Whoa, incredible. Okay, and that's called, in science, we call that electrolysis. Electrolysis. Okay, let's just do that one more time for argument's sake. All right, one more time. One more time. Well, that is incredible. All right. Now we're going to try a different science experiment. Okay, I'm going to move the battery out of the way over here. Get everything out of the way. This was the generator that we used, and it was amazing. Okay, put it back down there, and we got it. Okay, now let us try yet another one. You guys can see these beads inside here. There's little beads. All right, there they go. The little beads. And you can see the color of these beads are white. Okay, I'm going to take this light over here, purple little light, shine it on the beads for about 5 seconds. 1, 2, 3, 4, 5. And you're going to see the beads are now colored. Okay, what's happening here is these beads are coated with a material that's sensitive to the UV light, ultraviolet light, like the sun, and that's what this light does. It produces ultraviolet light. So, they were white before the light, but when I put the ultraviolet, it absorbed it, and the chemical inside changed color, and then we get these color beads inside. Okay, very, very cool. And that's a field of science that we call physics. Yes, physics. All right, let's try yet another one. We have this little bowl here, which is water inside of it. There's water inside, right? Water inside. I'll say it to the side so you can see it without any reflection. Okay, now I'm going to open it up like this. And there is nothing in my hand. My hand is completely empty. But if I reach into the water, I'm reaching into the water. I'm going to squeeze the water. And look what you see. This sphere, like a little bubble up here. It just fell right out. Here's another one. Just like that. What's going on here is it's actually in the water. And that bead is made of 99.9% water. Okay, it absorbs water and they grow in water. So they're really here, but you really can't see them until you take them out. Some people call them Orbeez, water beads. They're really made for plants. Instead of using water, you could put the seeds in these beads, and since they have water, they'll grow. Okay, so an amazing, amazing, amazing part of science. Let's close that up, yes, and put it right here. Okay, now another experiment which is here. Let's see. We're going to start with a bottle. Put it here. We're going to start with this. And this is an air pump. Yes. Okay. Then we have a cap for the bottle, the special adapter you see. Now, on your bicycle tire, that's where you put the air in, okay? Called the Schrader valve. It lets air in, but it doesn't let air out. I'm going to use that. And then we have a small little bottle of alcohol. Alcohol is a solvent. Okay. So we're going to take this, open it up, and put about 10 drops in our bottle. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops. Then what we'll do now is put the cap on it. Make it tight. So many kids think it's a baby bottle, but it's not. Now we're going to pump this up. In other words, we're going to put pressure inside of this bottle using our pump. And that's what a pump does. Put the pump on the valve, open it up like that. And now we're going to pump up this bottle and add pressure. There's no pressure now because you can squeeze it. So we're pumping it up, adding pressure to the bottle. And the bottle definitely, since there's air in it, getting harder to squeeze it. And we still have that little alcohol inside of this bottle. Okay, there we go. A little more pressure. And now, when I release the pressure, what I'm going to make, hard to believe, but true, is a cloud like in the sky. A real cloud will appear in this bottle. Okay? So we're still pressurizing the bottle. PSI, pounds per square inch, is the measurement of pressure, air pressure. It's just about ready. And now when I open it, you're going to see the cloud. All right, one more. Ready? Count of 3. 1, 2, 3. And there is that cloud. Okay? So when the pressure was high, there was no cloud. But when the pressure became lower, you got the cloud. So let's try it again. The pressure is low. There's no cloud, a little fog inside. But as the pressure gets high, it's all gone. And we're creating a cloud in science. Yes. All right, here we go. Look who's inside, pumping it up, pump up the pump, adding pressure, adding more PSI, pounds per square inch. Okay, everybody ready? So there's no cloud, but when I open it quickly, the pressure drops and the cloud forms. Ready? Count of 3. 1, 2, 3. Okay, give it another little try. I kind of opened up a little slower. That's why we didn't get that boom and the quick forming of that cloud. This is very, very pressure sensitive. All right, here we go again. Beautiful, beautiful thing. Science is a great thing when you're experimenting. Count of 3. 1, 2, 3. There we go. And there's the cloud. And it's just water vapor. We say cloud, but that's exactly what a cloud is. Well, it's particles, but also vapor. And there you go. Okay, very, very cool experiment in science we call a cloud. All right. We have a bottle of water right here. Okay, good bottle of water, right? All right, we have a bottle of water. So what we're going to do is I'm going to put it behind here and take another bottle. All right, so put the bottle of water right there, holding it up. Okay, here's this bottle. You can see inside on the top, there's another little bottle inside. I'll go a little closer. You can see it. See it floating on the top? There it is. Question is, could we make this little bottle sink inside the larger water bottle? So we're looking at it, and I'm going to say go down. You ready? Little bottle, go down. And the little bottle goes down very slowly. Look at that. It goes all the way down and all the way back up. Again, go down, little bottle inside the big water bottle, go down. And there it goes. It's actually going all the way down. Now, what I'm actually doing is squeezing this bottle. Again, changing the pressure, and that little bottle inside actually sinks because it's changing its surface area. In other words, it's squeezing it, giving less floating ability of that bottle, and it sinks down. This is similar to a submarine theory. So it's all about pressure. That's right, pressure. Just squeezing it, and it goes down. I also can make it stop just about there. If I control it, stay right there, little bottle, and kind of bobs up, go down more, and go up more. See that? So it's all about squeezing it, all about pressure, all about floating and sinking, all about science. Very cool. Very, 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 very cool. So again, there it is, pressurizing, and it's a submarine theory, similar to how a submarine actually goes under the water and goes back up. Okay, sinking and floating. Amazing physics, science, and you have it. Very good. So we'll put it here for a sec, and nice. All right, let's change the field of science just a little bit and do what's called a reaction. And a reaction is when something changes. This is a chemical reaction, so we're going to use chemicals. I'm going to start with this. Let us see. Okay, we're going to take this bottle over here. Put it there. All right, let me make a little stage over here so you can see it. Put it right there. Okay, we're going to take two of them. Put them right there. Okay, now I'm going to take a liquid here. I have this one marked B. I'm going to shake it up, and I have another one, and I hope it's A. So let's see. Yeah, it's A. We're going to shake it up. Now I'm going to measure some of this chemical out. Let's say, put a line, measure it, 50 ml, 50 milliliters. Put it here, close it up, it doesn't spill. Put it down. Let's put one over here for now so we know which is what. We have it, and let's pour it inside. There it is. 50 ml of that A. That chemical solution, which is lettered A. Now we're going to take the B. We're going to use the B, but before that, I'm going to add something to that B. I'm looking for it in my chemical bag, and it's here with the letter SM, salt mixture. Okay, so we're going to take just a little bit of this right over here, and we have a very, very, very small little chemistry spoon that'll actually help us take a little bit of the chemical out. So you ready? Here we go. Going to take a little bit of the SM, just a little bit of it, not much. Here we go, and put it in there. Okay. Close it up, and now we have to remember that we have to mix it solid. So here we go, shake it up. Now let's switch. We'll put, this was the A, we'll put it here. Now we'll do the B, that I added that salt mixture, yes, to it. We shake it up, we cleaned out the bottle. I open it up, we mix it all the way up, another clean. We're going to use another 50 ml, let's say. Okay, 50 ml coming right up. Take it and put it there. Okay, so this reaction is a change. When I mix both those chemicals together, I want to see a color change. So if it happens, we know the reaction is successful and it worked. All right, so let's move this out of the way. We're going to mix them. And don't take your eyes off for 1 second, because you may miss this seemingly magical experience if it works, because it is science and sometimes things don't work well. So you ready? Both liquids are clear. They have no color. So now we're going to mix them together. Ready? Whoop. No change. Let me put it over here. No change. Keep watching. Keep watching. Keep watching. See, it got a little darker. Became a little darker. A little purple. Now watch this. Watch what happens now when I add some more of that salt. Gonna add some more of it, and we're gonna see what does yes happen. All right, we're gonna see if we get it. Okay, let's do it again. We're gonna mix it again. So we have a little slight change, but we want more of a change. Ready? Mix it again. And again. Whoa. Look at that. Just like a dark grape juice color. Amazing. So the reaction definitely took place, that we were able to take this clear mixture and make it happen. Now the question is, can we make this dark blue disappear, change? Well, we're using science. I'm going to take the same salt mixture, put a little bit in my hand, and see if we could make it change. Okay, here it is. I'll put the cap on. Now I'm going to add the mixture to it. 1, 2, 3. Did it change? No. But if I mix it around, there it goes, back to clear. So that's a reaction. Things are changing. Science. A reaction in the field of science that we call, yes, chemistry. Very good. Very good. Very nice. Very cool. Amazing. How about we do another chemistry experiment? That's right. See what I have over here. Here it is inside here. The question is, what are these? I'll open it up and let's check it out. A lot of kids say matches, but it's not. It's just a Q-tip that is red instead of the white. So we're going to try something with this. Take one out. We have this Q-tip that's colored red. Now, we're going to take our bottles over here. This is water. I'm going to put it in the water. There you go. Still red. Have it in the water. It's still red. Let me use this one. It's a little higher. It may work better. So we're going to do a reaction with this, and let's see. So there we go. You see it's red. Okay? Very good. Very good. Very nice. Now we're going to take another liquid over here. We're looking. This is also clear. Going to open it up. Here we go. Put it right there. So here this is. It's red. But when I put it in this clear liquid over here, watch this. Amazing. The water remains clear, but it turns dark blue. Is that unbelievable? Dark blue. And the water's clear. The liquid's clear. Making you wonder, how could that happen? What about if I put it back in the water? Still blue. Ha! Let's take yet another clear liquid here. Okay? Very strange what's going on. Another clear liquid here. We're going to take it out. It's blue. And I'll just touch it with my towel. You ready? And now we're going to put this blue into this clear liquid and see what happens. Around, and magically, it turns back to red. Wow, that's really interesting. How could that possibly happen? Back to the original color, red. Even in the water, red. And it's coming out. Okay, what this is a chemical reaction called acids and bases. Acids are lemon juice, vinegar, acid, usually sour compounds. Bases are like soaps, okay? And this chemical, there was a chemical, red chemical on it, that when it mixes with an acid, it turns blue. But when it mixes with a base, it turns red. So it's just science, and the science of chemistry. And a very, very interesting reaction, if I may say. Really cool science. Really cool, really cool. And there it is. Okay, very cool science. We'll leave this here just for a sec, close it up. And that's the field of science that we call, yes, chemistry. Chemistry. And chemistry seems very magical unless you know the science of that. Very cool, very cool. Now, let's try something that you could actually do at home. And it's this. Now, what is inside that jar? Hard to see, but it's rice. It's uncooked rice. And we're going to try to do science with this uncooked rice. We're going to try to do a science experiment with this. So that's all there is in here is rice. There's no glue. There's no magnet. It's just rice. Okay? So just take uncooked rice. This is a peanut butter jar. I wouldn't use glass jar. I would only use plastic jar. It's a peanut butter jar. Simple. Open it up. And there's the rice right there. Rice. Put it there. Now, going to take a stick. I have a chopstick. Okay? And what I'm going to try to do is put the chopstick inside the rice and lift it up. Let me put it back here. Maybe you can see it better. Okay, let me come up. Okay. Very good. Actually, I'll lower it a bit. We're learning how to make a little stage here. Pretty cool. Use this one and put the rice right there. Okay, ready? And we're going to try to lift it with this. Okay. Seems like it's impossible. How could this lift it up? I don't know. Keep trying. Keep trying. There's no magnet inside. There's no glue. The rice is holding it. And it's about, again, pressure. I squeezed it. The stick will come out very easily. So the rice is now loose inside. But as we take the stick and force it down, we're causing the rice to go to the side, becoming pressurized, tighter, and it actually at some point will grip this stick. Ready, friends? All right, I'm trying again. Amazing. Amazing science. Really cool. Yes. So you can try it at home. It's just uncooked rice in an empty jar of peanut butter and a stick. It doesn't have to be a chopstick. It could be a pencil, a pen. I'll try it with a pen. Let's see. You ready? We'll try it with a pen. There's the pen. The pen. You can take the pen. It's a pen. All right. Put it in. Nothing. Put it all the way down. Nothing. All the way down. Nothing. All the way again. We hold it over here. My base is not that strong. It should be strong, but just for look at that. Let me take the top off. It's hard to see. Better this way. Try it again. Okay. There you go. It works. See? Lifts it right up. Because it's forcing the rice on the sides. It's all gripping together, and it actually grips. Yes, the bottle, and lifts it up. It's not a very strong grip, so I really wouldn't shake it because it could fall, and you'll have a mess on your hands. Very cool. So remember, it's just an empty peanut butter jar and uncooked rice with a stick, and there is your science experiment in the field of science that we call physics. Very cool. Put that back over there. Take out a little mini stage, stand, put it over there. Now, over here, we have a little liquid inside of this tube. But when I bring this near it, you're seeing it spike? Because these are magnetic material inside, and there's a magnet in here. So when you bring the magnet near it, is when you get these spikes because it's reacting to that magnetics. That's right, magnetics. Okay? It's a magnetic fluid suspended in water. And then when we bring a magnet near it is when you get the spikes because it's identifying, recognizing that magnetic field. Really cool. Look at that. Follows it. Really nice. And you get those nice spikes on that. Okay. Very, very good. Okay. All right, here we go. Magnetics. Yeah, very, very strong magnet. Just magnetic particles suspended in a liquid. Really cool. Look at that. Wow. There we go. Now we're putting it back. Amazing. And science is what it is. Okay, let's try yet. That's right, another experiment. Be very careful here. We're looking what we have. Whoa, yes, we have it right over here. In this case, we have it. And what do we have in this case? Let's see. Opening it up, we have this. Looks like a flashlight. In order for a flashlight to work, you need a source of electricity, which are batteries. Yes. So we're going to put the battery in this flashlight, opening it up slowly. All right. Put the battery inside. Put the cap on, and the cap has the switch of a flashlight, making it work. Let's put it on, and let's see if this really is a flashlight, or is it something else? We're going to find out. Huh. It's a laser, a little laser light. Okay, I'm going to take this light, use this for our stage again. I'll put it right there. All right, now I'm going to take in this little box, metal box, I'll open it up, see what I have in here. A piece of paper. Paper's right there. And the color of this paper is black. So I'm going to shine the laser light on this paper. And yes, let's see what does happen. And it's science, yes, the science of physics. Here it is. We'll put it on. I'll hold it in my hand. And let's see. It's on the paper. Whoa! What? Where did it? What happened? What? Amazing. The paper bursted into fire. No smoke, no ash, no nothing. What about this laser that made that happen? What about the paper that made it happen? It was both of them. Let's try it again. Our light is right over here. Yes, a laser. Light amplifies simulation emission of energy. Wow, laser. A little bit of paper, black paper. So the color black absorbs light, becomes hot. This laser is modified, it's changed. I modified it. I made it stronger. This is treated with a chemical. So the laser got hot, heated the paper, and burnt the chemical in the paper and burnt it. So we'll try it again. Put it on, our laser, on the paper. Close it. I have to find the focal point where it's sharp. Just about over here. Whoa, and there it goes. Amazing. That's another example of a physics, you got it, experiment. Really cool. Take the battery out because it does get hot and keep it there. And this is something you really can't try at home. When you get to college, you'll be able to do a lot of these science experiments because you have learned chemistry and physics, which is very important. We put it back, and there we go. Safely, securely, and it's done. All right. Okay. Let us yet try another chemical reaction. Ln. So we have this Ln and P1, the chemicals inside. Let's see what these chemicals could do. I'm going to take a bottle over here. Going to put water in it. I'm going to change my little platform again. Okay, this is my little camera stand. Change it again over here and get it. Okay. We're going to take the Ln put about 10 drops inside. Going to add some water to that. Three more. And we'll notice this liquid has no color. It's clear. Okay. Interesting. Now we're going to take another empty jar. For now, I'll place this here. We're going to take this P1. Potassium. This is an experiment of how you make paint. P, paint. Paint is chemistry. The paints you buy are all made with chemicals. Okay, we're going to add this to the Ln. All right, let's see. Ready? Okay, we're going to add it to it. Put the cap on. Put a little water in here. Okay. Also, this liquid is, yes, clear, colorless, transparent. Both of them are. We're going to mix them together. So here it is. Now watch what happens when I add P1. Ready? 1, 2, 3. Whoa. How's that? Looks like orange juice. Really cool. But very simply, it's how one would make paint. Okay, again, something you can't try at home. When you get to college, you learn the chemistry of this. But really cool. I know it looks like orange juice. That's why I have to be careful. Someone could think it's orange and drink it, and it's dangerous because it's chemistry. But really cool. So these chemicals combined, the potassium mixed with the sodium, mixed with that lithium, L, N. What could the N stand for? Nitrogen? Yes. And you got this really very, very nice color. So that's the chemistry. And as you see, they use chemistry to make paints. Chemistry can make so many things. Amazing, but so very true. So really cool. I have to dispose of it properly. So for now, whoa, let me leave it over here. So that was really, 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 really cool. Let me see if I could do another one. I can. Another one. Let me see what I have. I have my little chemistry bottles right over here. and I'm getting this stuff called, actually, it's this one I want to try. It's a calcium plus a soap. And let's see. Let's see where that soap is. It's over here. They're both clear again. Okay. So, we're going to take this. Going to shake that up. Put some of this calcium. Calcium. Ca is the chemical formula. Put some in there like that. Add some water to this. And when you add water to something, you're diluting it, making it weaker. Remember, the formula for water was H2O that we did at the beginning. I want to do that one again because it's so cool to pop those hydrogen bubbles. All right there, guy. Let's see. There we go. Mix it up. Clear. Leave it here for now. Then let's take that soap. Yes, soap. Another bottle. Amazing. Here's that soap. Shake it up. Ooh, what a mess. Okay. And we'll dilute that. Add water. Simple. Dilution is a famous, famous scientific word. It means to make weaker. Not only with water you could dilute something with, but the universal solvent was always H2O, which is water. Okay, let's check this out. Clear liquid one, the soap, the calcium. I'm going to mix them together. 1, 2, 3. Whoa! Looks like milk. Wow, what is this? You know what this really is? It looks like milk. Something used all the time, I think. I just made chalk. If I were to dry this out, in other words, remove the water, it would become chalk. Amazing. So you're seeing that with this chemistry science, you can make so many things. Amazing. Look at that. What a liquid. Just like milk. Boy, it's like a kitchen thing here. I made the orange juice, made the milk, but as you know now, this is paint and this is chalk. But it looks pretty magical. So science, definitely different than magic, but it looks like magic. An amazing field, a really amazing field. Okay, there we go. Put it back over here, out of the way, so I don't do the famous thing called spilling, which is so popular when you do science. Things fall all over the place, and then you have a mess. Okay, good, 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 good. All right, here we go. Now, you know something, scientists, they make paint, they make chalk, ink, so many things. They make furniture, wood paint, wood stains, cleaning stuff. They also make toys. They hire scientists to make toys. And that amazes me as a scientist. I see toys. First thing I want to know is, how does it work? And when you learn how something works, you are learning what's called science. That's simple. Once you learn how something works, you are learning science. That's right. Okay, so a toy. Here we go. I'm reaching over to get it, and here it is. This, as you know, is Mickey Mouse. Let's check him out. All right, I'm learning how this camera works here. Mickey Mouse. Okay? Now he's on this stick. And Mickey Mouse will listen to me. I'm going to hold it this way so you can see it. I'm going to say, Mickey Mouse, go up. Mickey Mouse, go down. Mickey Mouse, flip. Mickey Mouse, go up backwards. Mickey Mouse, flip forward. and up again. Now, you really think he's listening to me? I don't think so. What I'm doing is squeezing it. This is a very old toy. And the reason why it works is when you squeeze it, there's a string right there that becomes tight. And as that string becomes tight, it makes this little figure flip. So simple, but to me, amazing. Look at that. It's an old toy. I'm from New York, Queens. I haven't seen them in many stores anymore. They're available online. And you would call them acrobatic toys. You could actually make them. I made it myself, one of them. It's not that hard to make it, but sometimes it's cheaper to buy something. But you could actually make one for a science project. It's a little involved. You need your parents. You can make it out of cardboard, too. This is wood. It's easier with the cardboard, but the wood is much more solid. And that is really cool. It's very acrobatic. He listens to you, but you're really squeezing it, so you're controlling how it does, yes, work. Look at that. All right, there we go. Very cool. Gotta love this. Okay, very nice. Let's see what else we have related to science. Of course, yes, of course. We're looking in our bag, and I found it over here. Did I find it? Yes. We're reaching for it, and I have it. It's here. You're wondering what this is. Pom-poms on a stick. So let's see. Blue, yellow, green, red. I'm going to pull the yellow one. The red one goes up. Okay, I'm going to pull the green one down, and that goes up. I'm learning how to use this little camera. Okay. So obviously, there must be a string that attaches it together. Okay? All right, let's see. But if I take the red one and pull it up, what? If I take the blue one and pull it up, the green one should go up. But now look, this one here is moving without the other side moving. So that's really strange. If I pull the red one up, and now that goes down without the other one moving. So how could that be? How could this one go up and down and the other side's not moving now? And this is this way, and that's that way. But when I go like this, it goes up, and this one, I have to go this way, gets stuck. Okay, it's probably twisted. No problem. And this way here. All right, there it is, and up. So let me open it up. We'll show you the string. I'm opening it up. Where's the string? Where's the string? I don't know. How is it connected? I put it together like this, move it, don't know. But if I pull it up, it's working again. This side, I think I have it twisted. So how is that possible? Why is it moving now? And when I open it up, you don't see anything. Anybody have any idea what's happening over here? There's no string. No string. So close it together. And there it goes. Any idea? It's really simple. It's a magnet. It was connected in the middle. See, it's connected there, the blue, but it pulls apart. It's a magnet. And they grab together. Amazing. Science, 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 science. All right, let me go because we didn't get it clear and it's so new for me. Let's do that hydrogen one again. Let's see. And I can show you all the parts now, but it may take time to do it. Let's see if it's, I don't know. It may take me time now. So here it was, the water. I will put it over here on top over there. But this is not a good base. Okay, this is not a good base. Let me try this one over here. Okay, there it is. See that? And then what I did was I put it in the soap here. And that you can't see. All right, let me raise that up a little bit. And what I'm doing is just making what's called hydrogen and oxygen bubbles. So let me see if I can make it happen again. And I'll explain it to you better. And we can see it a little better this time. I'm connecting a battery to it. There it goes. Okay. All right. Inside here, you'll see some bubbling happening. Okay? All right. Now, this may take a while to make the hydrogen and oxygen. Let me see if I can lift this up carefully so you can see it safely. Okay, so let me use this one. I hope this works. There you go. Okay, now I got it right. This is our lighter. Let's see. What? What? I love this one. Let me try that again. You heard that loud pop? Just bubbles forming over here. There's bubbles forming. Wow. In here, there's two electrodes, two pieces of wire. There's current going through because there's salt inside. It's breaking down that water, H2O, into hydrogen and oxygen. And this is soap inside, making bubbles of hydrogen and oxygen. And they're explosive. Try it again, guys. Amazing. What? I mean, you probably, I'm going deaf how loud it is. I can't believe it. All right. I'll go closer with the camera now. I'm getting better at this, I think. Okay, let's see. Come this way. You see the bubbles forming? I'll try to light them this way. I'm not a good photographer. What? Sorry, guys. I guess when I grabbed the phone, I knocked myself off. Yeah, this is really rough. Okay? So that's really interesting. As soon as you touch a phone, I know, everything goes off. Okay, so this is really cool. I'm going to do another one. Wow, it's so loud. I need earmuffs. Wow. So that is amazing how from water you could get this. And this is going to be used in these new cars that are coming out called hydrogen cars, because hydrogen, as you see, with oxygen is a very, 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 very powerful fuel. Amazing. I got to try that one more time. This is really working well. It took me a while to figure it out because I had to seal it. You know, I had some leaks in it, and the battery, the right battery I had to get, but it really works very well now. And this is like a little barbecue lighter over here. It's pretty good. No matches. Wow. Let's try it again. See the bubbles right here, and boom. What a sound. Amazing, amazing, amazing science. Here we go. All right, here we go. Wow. You wouldn't believe how loud this is over here. It just goes to show these little bubbles have so much energy inside. And this is called really basically is called electrolysis, that was actually breaking the water down to its prime components. Water, again, H2O. 2 parts hydrogen, 1 part oxygen, and they're right in the small bubbles. Now let's light them again, so I won't hear all week. I don't know. Here we go. Wow. Incredible. Works well. Something you cannot try at home. When you get to college, you learn how this works. I even had trouble with this, but I just got it working last night. I thought about it for a while, a simple way to make it without glass, because as you see, things drop and break, and we don't need that right now. I can't even hold the camera right, the phone. So really, 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 really cool. One last time, we'll try it. Wow. To me, it's incredible because it's actually working, and it's amazing that these bubbles have this oxygen and this hydrogen. Here we go again. Let's light them again. Exploding bubbles, exploding bubbles. That's it. Here we go. Oh, amazing. I'll disconnect the battery now, and the reaction stops. So again, electrolysis is what this is, electrolysis, okay? Electrical. Electricity and water, which is usually a dangerous combination. Anything with electricity is dangerous unless you understand exactly how it works. So friends, that was very interesting to have you here, and we'd like to thank Magical Memories for actually broadcasting the show. They're really, really great people, and if you're having a party, any event, call Magical Memories, and they will take care of it for you. They have so many events. They're great people. They're great service, great people they have working for them. I work with them. They're really, really, really great people. Magical Memories. Give them a call. They'll take care of all your party needs. Everything. They got it covered and always do a very great job, and highly recommended. Okay, friends, Vinny Voltage out, and thank you very, very much, and hope to see you again very soon. Take care, friends, and bye. Bye, bye, bye. Bye.
We want to thank the guys from Magical Memories. They gave us a fantastic night for our daughter's bar mitzvah.
So much Magical Memories. They literally made my night completely perfect. They helped with my quinceañera.
Steve made my sweet 16 so much fun. I had such a wonderful night. It was the best night of my life.
Magical Memories was amazing. We had a wonderful time at our wedding. It was amazing. I know. Everyone is.
Photographer, everything was wonderful.
We just finished watching a great show of Magical Memories.
Everyone did a wonderful job. My kids had a great time. It was totally awesome. Thank you.
Magical Memories was amazing. I had the best time ever.
It was so much fun. We had such a fucking blast.
Everything was perfect.